DeepSeek just dealt another blow to AI companies and released a multi-modal model. On the benchmarks, it outperforms DALL-E 3, Stable Diffusion XL, and loads more, because apparently Nvidia and most of tech wasn't down enough today. So we now have V3 from them, we have R1, and we have Janus. Will they be able to compete with Sora for video soon? I hope so. Let's see some demos and then talk details. The models are available for download from Hugging Face, or you can use the demo on there as well. I'll leave a link to it in the description down below. Now, Janus Pro is available in 7 billion parameters and also 1.3 billion. I'm going to be using the 7 billion one. So let's go ahead and give it some tests. We'll start out on the multimodal understanding. So I've given it a latex formula here in an image, and let's just see if it can convert the formula into latex code. There we go, it actually took about 50 seconds. Now I'm going to imagine most of that time was actually due to Hugging Face itself. This was actually really slow to load this website because I imagine it's being hit by a lot of people at the moment trying to test this model out. Let's go ahead and just check if this latex code is correct though that it's generated. So putting it into a latex renderer, you can see we get the original image back, so it's worked nicely. Let's try another image and see if it can do some landmark recognition. So I've given it a picture of Big Ben here and I'll say, where is this and why is it significant, and see if it can identify that. Now, one thing it is worth noting is that the input for the model is only taking images that are 384 pixels by 384 at the moment, which is a bit of a big limitation, especially when it comes to some more complex OCR. But let's go ahead and test. There we go, after about 50 seconds on Hugging Face, after it had to acquire a GPU, you can see it's correctly identified that the image is of Big Ben, and then it's explained why it's significant as well. So the last thing I'm going to test on image input before we get onto image generation is going to be its OCR. Can it correctly identify that this text here says subscribe? Something you should definitely do. Let's find out. The answer is yes, it's correctly identified that the text in the image says subscribe. I tried to give it a bit of a hard example there by using the handwriting. I do imagine that it's going to fail a bit when the text is quite small in the image, because as I said, it's only limited to 384 pixels at the moment. But either way, for an open model, it's pretty impressive. Let's move on to image generation now. I'm going to ask it for a cute corgi running through a field of candy. So let's go ahead and hit generate image here. Now, while this is generating, I do want to mention that this is actually the part that I've seen some skepticism on. It seems the general opinion is that the image input is impressive, but the image generation is less so, feeling pretty similar to DALL-E 3 despite the fact that it outperforms it on the benchmarks. Again, it is always worth mentioning this model is under the DeepSeek license, which is essentially anything you want except for illegal usage and military usage, and that it's also quite a relatively small model at 7 billion parameters. So it's probably not going to perform as well as models that you might see like Flux, but it's still pretty good for that open model. Let's go ahead and wait for it to finish. And there we go, you can see the pictures of my cute corgi running through a candy field. Now, I can see from this what people mean. The image generation itself isn't very high res. The actual pixel size of this was 784 by 784, and you can see there's a lot of detail missing at the moment. So it's not the best model, but that could be due to the prompt that I gave it. So let's try another one. I'm going to use one of the example prompts they had here on Hugging Face. Essentially, it's an eye with a load of detail, and then above it, there's supposed to be a stone-like structure resembling part of classical architecture and have a mysterious vibe to it. Let's go ahead and hit generate. There we go, it's generated the rather creepy, or I guess mysterious prompt of that eye there. And you can see, I still think it's missing out on some of that finer detail. It's still not going to be as good as some of those models we have from Flux, but again, you do have to remember that this is something you could end up running locally, which is actually quite insane. Now that you've seen it, let's move on to some of the technical details. Now I'll leave a link to that paper in the description down below. Starting out, they say their main advancements were in an optimized training strategy, expanded training data, and scaling to a larger model size. If we go ahead and take a look at their benchmarks, for multimodal understanding, you can see that the Janus Pro models come out on top compared to the rest with the best average performance against LLM parameters. For image generation, they also top the charts in terms of accuracy. One grain of salt here though is that these benchmarks don't actually test image quality, something that's quite hard to do outside of image arena style tests. The tests are actually checking for instruction following capabilities, so this benchmark actually shows that Janus Pro excels in following dense instructions for text to image generation, not that it's necessarily going to give you the best image out of it. Next, something always amazing to see from DeepSeek is how much did this cost in resources to train? Well, the 1.5 billion parameter model took 7 days, and the 7 billion one took 14 days. The 1.5 billion parameter model was done on a cluster of 16 nodes, and the 7 billion one on 32, each of these equipped with a NVIDIA A100 GPUs. In terms of money for these resources, I've seen some rough calculations that this would amount to be around $120,000 US. Now remember, this is a model that beats DALL-E 3 that likely costs somewhere in the millions, which is absolutely insane. Now, the paper has a load more technical details and also more examples of text to image generation, as well as its multimodal capabilities, but I actually think the most important part of it is in its conclusion. This is where they go ahead and describe its limitations. One of them we've already mentioned, and that is the input resolution is at 384 by 384 pixels. As I mentioned, that's really going to limit it on the fine details of OCR. But the other one is that it has low resolution text to image as well, and it also has some reconstruction losses in that process. This means that while it is good at following your prompt well, it's going to lack the fine details, especially in more complex areas like faces. Although maybe increasing the image resolution can help you to mitigate this. So what do you think? Is China destroying the US in the AI race now? Personally, I want to take a more optimistic approach. I really liked Jan's response here. He's a chief AI scientist at Meta. He says because that work is published and open source, everyone can go ahead and profit from it. And that is the power of open research and open source. Let's discuss this in the comments. And while you're down there, subscribe. And as always, see you in the next one.